Hey guys, welcome to day 17 of 100 days of code. Now today we're going to be focusing on how we actually create the classes that we've been using in yesterday's lessons. Today's final project that we're going to be building up towards is a quiz game. So we're going to be able to create a true-false quiz, and we'll be able to play the quiz, answer the questions, and keep track of score. But we're going to be building this completely using object-oriented programming. We're going to be creating our classes ourselves and then using the objects created from those classes in order to build this game. And once you're done, this is what you'll be able to create. Question 1, a slug's blood is green, true or false? True. Now, if you want to have a play around with the final project to get a feel for how it works, then you'll find a link to this final version of the quiz game in the course resources. But once you're ready, then head over to the next lesson and we're going to get started by learning how to create our own custom classes. So for all of that and more, I'll see you there. Throughout all of yesterday, we've been using other people's classes. And we said that a class is simply just a blueprint for creating an eventual object. In this lesson, we're going to talk about how we can create our own classes. So our own blueprints, which we can use to create our own objects. Now, let's go ahead and create our own custom classes in code. Go ahead and create a new project, either in PyCharm or Replit, wherever you prefer. And we're going to name it Day 17 Start, and then hit Create. And again, as always, once you've created your project, it's time to create your first file, which we're going to name main.py, and then we can collapse our project sidebar and focus on the code. So how do we create a class? The syntax looks very simple. You have the class keyword followed by the name of your class, and then a semicolon, and then all of the code that's in your class will follow this and it will be indented. Let's create our very first class in Python. As I mentioned, the way that we would create a class is first by using the class keyword, and then we get to give our class a name. Let's say that we're building a website and we need a class to model our website's users. So this class is basically going to be the blueprint to represent what our users have and what they can do on our website. Let's call our class user, and then we finish this declaration with a semicolon as usual. And everything else that's going to go inside this class is going to need to be indented after the semicolon. Let's start out with a completely empty class. Our user class is going to do absolutely nothing for now. However, because I've created my blueprint, I can already use it to create my first user object. So let's say I wanted to create a user1, and I'm going to create it using that class, which notice it's now being recognized by PyCharm, and it's got the C symbol next to it. And of course, to initialize an object from a class, we have to add the parentheses at the end. Now, we get an error here because there's an indent expected. So basically, Python doesn't like it when you create something like a class or when you create something like a function and you have a semicolon, but you don't have anything inside that function or class. For example, if I just immediately wanted to print hello afterwards, I get exactly the same error, indent expected. It's expecting this a function that you've created or this class you've just created to have some sort of content before you go ahead and do something else. So how can we fix this? Well, if we actually really want to leave this function or this class empty, we can use a keyword which is pass. And all it does is it just passes. It says, I don't want to have a go right now, just continue to the next line of code. And this gets rid of our errors both in the function declaration as well as in our class declaration. We've now essentially completed the first step towards creating our custom classes, which is writing the declaration and then building an object called user1 out of that class. And we've also seen how to name classes in Python. Now, the name of the class should have the first letter of every word capitalized. And this particular style of naming in programming is known as Pascal case. So if you think of Blaise Pascal as a person, then we know that everybody's name, every person's name, has the first letter capitalized and also the first letter of their surname or their middle name, and basically every subsequent name capitalized. Now, this is different from another type of casing which you may have come across, which is called camel casing. And camel casing is only different from Pascal case because the first word is lowercase, but every subsequent word has its first letter capitalized in exactly the same way as Pascal case. And finally, we've also come across snake case, where all the words are lowercase, but they're separated by an underscore. In Python programming, you won't see a lot of camel casing. You'll see Pascal case being used for the class names, snake case being used pretty much to name everything else. Now that we've seen how we can create a new class, even if it's a class with nothing inside, and we've seen how we can create a new object from that class by using the same code that we used in yesterday's lessons, the next question is, well, how do we create an attribute for that class? Well, one of the easiest ways of doing this is simply tapping into your object and then adding an attribute. So we could say user1.id equals 001. And we could add as many attributes as we want just by using this method of using the dot notation after the name of the object and then just adding any piece of data we want. So now if I go ahead and print user1.username, you'll see that this attribute now exists in this object. And you can see the value that's held in that attribute being printed in the console. So just a quick reminder, an attribute is a variable that's associated with an object. So it's almost as if we just created a new variable, but in this case, we've attached it to an object. But here's a question though. If we had lots and lots of attributes like this, and every single time we create a new user, let's say we created user2, and we had to do the same thing, create it from the class, and then say user2.id equals 002, and user2.username equals Jack. And this is a little bit prone to error because it's perfectly valid for me to make a typo or change the name of an attribute where I end up with something like this. So is there a way of making this simpler? How can I specify all these starting pieces of information when I create my object from the class? Now, in order to do this, we have to understand something called a constructor, which is a part of the blueprint that allows us to specify what should happen when our object is being constructed. And this is also known in programming as initializing an object. When the object is being initialized, we can set variables or counters to their starting values. In Python, the way that we would create the constructor is by using a special function, which is the init function. And you can tell it's special because it isn't just the def keyword and then the name of the function. It's got 2 underscores either side of the name. And this means that it's a special method that the Python interpreter knows about and knows that it has a special function. Now, what is the special function? Or it's normally used to initialize the attributes. So if inside our class we add this init function, and you can see as soon as I write def and then init, I've already got autofill helping me, so I can just hit enter once it's selected. Now inside this init function is where we initialize or create the starting values for our attributes. Now the important thing to remember is that the init function is going to be called every time you create a new object from this class. For example, if I print, then every time that this construction happens, when we create a new user, then this print statement is going to be triggered. So you can see here, this print statement gets triggered, and then we print the user one's username, and then we've got another user being created. Just as a quick reminder, the attributes are the things that the object will have. And they're basically just variables that are associated with the final object. So for example, if you're constructing a car object, then one of those attributes could be the number of seats it has. And normally that's equal to 5. So how do we set these attributes in the constructor? Well, this is what the code would look like. We have our init function. And inside the init function, in addition to this thing called self, which is the actual object that's being created or being initialized, in addition, you can add as many parameters as you wish, and that parameter is going to be passed in when an object gets constructed from this class. And once you receive that data, then you can use it to set the object's attribute. This is what it would look like when we actually call our constructor. We know that we can create an object by calling the name of the class and then adding the parentheses. But if inside our init function we have some additional parameters, then we can also pass in data to those parameters, which will be used to set the attributes for that object. So in this case, once this line of code has completed, then mycar.seats is going to be equal to 5. And this is exactly the same as if we created our mycar object first, and then we said mycar.seats equals 5. It's completely the same. But it does make it a lot quicker when you're creating a lot of objects that need all the same attributes. Let's see how we would do it here. We've got our init function already declared. So if we wanted to pass over a user ID when we construct our objects, we can add that as a parameter. And then inside the init, we can say self.id. So self.id is going to be the attribute that's associated with this class. And we can set it equal to the user ID that's passed in when any user gets constructed. So now when we create our user, instead of creating these attributes later on, at the time of construction, you can already see that we can add a user ID. So let's give it the same ID. And now let's add another attribute. So we're going to pass in the username. And I'm going to set the attribute self.username equal the username that's passed in. Notice how in this case, I've named my parameter user_ID, and that value is going to become the self.id attribute. So notice how these two actually have different names. You can name either of these anything you want. It's normally convention that you'll see the name of the parameter be equal to the name of the attribute, but you don't always have to stick to these rules. Now let's go back to our constructor. Whereas previously it was empty, now we have our user ID being passed in, and I can now pass in the second attribute, which is the username. So my username was going to be Angela. And now we've created a new user, which is user_1 from this user class, and we're initializing it with these starting values, where the first value is going to become the user ID, which is going to be the self.id, and the second value is going to become the self.username. So now if I wanted to print the user1's username, then I can simply write user1.username in exactly the same way as before, or if I wanted the ID, it would be user1.id. So now let's comment out the rest of the code and hit run. And you can see we've got the user ID being printed here. Now remember that when you add parameters to the constructor, which is the init function, you're now saying that whenever a new object is being constructed from this class, it must provide these two pieces of data. If we uncomment this and you try to run it, you'll see you get an error. And it says that on line 12, This user is being created from the user class. But according to the init, we're actually missing two required arguments, user ID and username. So now when we create any object from this class, we have to provide the user ID and the username. But this is now much more convenient, right? Well, we previously needed 3 lines of code, we now only have 1. Now, sometimes when we're creating our attributes, we might want a default value to start with. And if at some later point in our program, we want to modify it, then we'll do it at that point. But it doesn't make sense for all attributes to be initialized when we actually create our object. So for example, in our case, let's say that we were coding up the Instagram app, right? Well, each of the Instagram users, they would have an ID, they would have a username, and they would probably have a follower count. So they might have something like self.followers. This is always going to start out as 0, right? You start a new account, you're going to have 0 followers. You might get some followers later on, you might not. But it doesn't make sense for followers to be something that we have to provide whenever we construct a new object. It seems very wasteful to have to always write 0 when you construct any object from this class. So in Python, we can also provide a default value, just as I've done here. Instead of setting it equal to one of the parameters that's being passed in when this class is being initialized, instead I'm just setting it to a value, which is 0. Let's get rid of that from the initializer because we now have a default value of 0. And if I go ahead and print my, let's say, user1.follower attribute, and I hit run, then you can see it's 0 because all objects being created from this class will have a follower attribute that's set out to 0 to begin with. In addition to creating attributes, we know that we can also create methods. The attributes are the things that the object has, and the methods are the things that the object does. Let's say that we were creating the car class and we've already created the seats attribute. Well, later on, we might decide that we want to call a method to change that seat attribute's value. So for example, I've been watching a lot of truck racing recently. And one of the things that people do when they mod their cars for racing is they take out some of the seats. This way it reduces the weight of the car and it means that you can go a bit faster. So in our car class, we might in fact have a method where the car can enter race mode, where the seats are dropped from 5 to 2. This is what the method would look like. Inside the class declaration, we have a function, but remember when a function is attached to an object, then it's called a method. This method looks exactly the same as how we've created other functions. We have the def keyword, we have the name of the method, we have some parentheses which can take inputs, a colon, and then the body of the method. So in this case, all it does is it gets hold of the object and then the object seats attribute and then changes it to 2. So now when you call that method, all you need to do is get hold of the object and then use the dot notation to call that method enter race mode, and of course with the parentheses at the end. So let's say that while we're modeling our Instagram user, we want to have a way for the users to follow each other, right? And when they follow each other, their follower counts obviously go up. So let's define a new method. So we're going to use the def keyword and then we're going to name our method follow. Now a method, unlike a function, always needs to have a self parameter as the first parameter. This means that when this method is called, it knows the object that called it. Now, in addition to that self parameter, we're also going to pass in the user that we've decided to follow. So now let's say that we actually had two attributes, the followers and the following count, right? So they both start from 0, so two default attributes. But when a user decides to follow another user, well, in this case, the user who we're following, their follower count goes up by 1, and our own, so the self dot following count goes up by 1 as well. So the self keyword becomes quite important when we're working with classes and objects. It's a way for us to refer to the object that's going to be created from this class inside the class blueprint. So you'll never see self when you're using objects, but you see it a lot when you're writing your code inside your class. Now let's go ahead and call this, and let's say that user 1 decided to follow user 2. This is the user 1 object, and this is the follow method from the user 1 object, and then the user 2 is the person who we're going to follow. So now let's go ahead and print the user 1's follower count and the user 1's following counts, and let's do the same for user 2 as well. You can see once this method has run, then user 1's follower count is still 0, but user 1 is now following one person. User 2 has 1 followers and has 0 people that it's following. Now that we've seen how to create our own custom classes, we're finally ready to build the quiz game. Now this game is going to be a simple true-false game, so a question will be asked to the user and they'll select true or false, and then we'll tell them if they got it right or wrong and give them a score. Now to begin, the first step you'll need to do is to download the zip file with all the starting code from our course resource website. Alternatively, if you're already logged in on Replit, simply fork the project and then click on these 3 dots to download the zip file here. And once you've extracted the actual folder quiz game start from the .zip file, then we're ready to go ahead and open it using PyCharm. In PyCharm, we're going to click open, and then we're going to navigate to the place where we have our quiz game start, which in my case is in the downloads folder. PyCharm should automatically configure the latest version of Python you've got installed as the interpreter, so you can go ahead and close these pop-ups. And if we open up our quiz game start folder, you can see we have 4 files: data, main, question model, and QuizBrain. And over the course of the next few lessons, we're going to be writing the code in all of these files so that we end up creating our final quiz project. The first task that we have is to create a model for a question in our quiz. If we had a question object, well, what kind of attributes should it have? It might have a text attribute for the question text, and it might also hold an answer attribute, which is going to be the correct answer to that question. Now these 2 attributes should be initialized with a value when a new question object is created from this class. For example, if our first question was 2 plus 3 equals 5, which we know the correct answer should be true, well then we might write the code like this to actually initialize a new question object. And when this initialization goes through, the constructor code inside the question class will take these 2 pieces of data and then add them to the corresponding attributes, the text and the answer. And so our new question object will have both of these attributes initialized with a value when a new question object is being created. Inside your project, go over to the questionModel.py file and go ahead and create a new class called question, and that question class should have an init method which will initialize 2 attributes, the text and the answer, just as you've seen in the previous slides. Pause the video and see if you can complete this challenge by creating this class. All right, so we know that to create a class, we first have to use the class keyword. And then in our case, the name of the class is going to be called question because we're modeling what a question would be like in our game. We know that each of these questions have two attributes, a self.text and a self.answer. And those two attributes are going to be initialized when we create a new question object. So we need the init function in here. And we're pretty much going to use the autofill. So once you write def and then you write init, you can see it in the drop-down list and then just hit enter and the code will be inserted automatically. This way you don't have to remember the exact order of the parentheses or where to put the colon, etc., etc. Now inside the init function, we're going to set up two attributes, as we said. One is going to be called text and one is going to be called answer. And if we want to create an attribute, we have to use this syntax, self dot, and then the name of the attribute. Because eventually when we create a new object from this class, say a new question object, then we're going to be passing in these two items, a piece of text, which is going to be the question, and then either true or false as the answer. And then later on, if we wanted to access the text, then we would say new question dot text. Now, of course, at the moment, these are all yellowed out because it seems to have no effect. There's no way of receiving a value for each of these attributes. And to do that, we have to add some inputs inside the init function. So let's just call it qtext and qanswer. You can, of course, call these parameters anything you want. But the important part is you set the self.text to that first value and the self.answer to the second value. So now when we actually go ahead and print this new question.text object like we have here, then it will go ahead and actually fetch this value into the output. If you go to run and then select question model, you can see that is what gets printed in the console. Let's delete those two lines, and now we have completed our first task, which is creating our question class from scratch. Now, in the last lesson, we created our question class. In this lesson, we're going to be creating a question bank of question objects. Notice how we can create a question object by using the name of the class and then giving it some inputs for the question and the answer. Now, if we create a whole bunch of those and then put them into a list like this, then we can create a question bank of questions to use in our quiz. If you take a look inside the data.py file, you'll see that I've already included a whole bunch of questions inside here. And you can see it's got some text and it's got some answer. So the exact structure of this file is that it's got a whole bunch of dictionaries, 12 in total, and all of these dictionaries are saved inside a list, and that list is called question data. Now, when you first come onto this file, you'll see some warnings, these little yellow squiggly lines. And the reason is because it would expect for proper formatting, each of these dictionaries should be indented inside the list. Now, in terms of actual functionality, this won't change anything. The indentation of the items in a list are not as important as the indentation in, say, a method or a for loop. But it's still better to get rid of all of these warnings. So what we're going to do is we're going to select everything inside this file. We're going to go to code and then auto indent lines. And this, you'll notice, has now auto indented all of the dictionaries inside the list. Now, you'll still notice some red squiggly lines. So in this case, the reason is because the line is too long. It's greater than 120 characters. You can see that's where the cutoff is. So in PyCharm, it's really easy to separate lines. If you just identify a good spot in that line, hit enter, and it will automatically add some quotation marks around it so that it still behaves the same way as before, but now it's on separate lines. And I'm going to do the same to line 8 as well. Now the final warning expects a new line at the end of the file, so let's give it that. And the last thing that you'll notice here is that there's a squiggly line here under backrub because that is a unknown word in the dictionary. So if you want to, you can actually save words into the dictionary to get rid of all of these squiggly lines. This is actually a name of a company, so it's probably not going to be in the dictionary. But if you go ahead and put your cursor on it like this, you'll see a little light bulb light up, and you can go ahead and select Save Backrub to Project Level Dictionary. And then that will get rid of all of your warnings and errors, and you'll see a nice green check mark in the right corner. Now that we've done all of this formatting with the data, let's really examine it. What we have here is a list of dictionaries. Each of the dictionaries have the same key for the question text and the same key for the question answer. So what we need to do is we need to be able to bring this question data into the main.py file, but instead of having a list of dictionaries, we want a list of question objects. We know already that we can create a new question object by simply constructing one from the question and then giving it the required inputs. But in order to do this inside the main.py file, we of course have to import the question model, and we'll also need to import the data.py. So from the question model, I'm going to import the question class, and from the data file, I'm going to import the question data. Now that you've got both the question data and the question class, your goal is to create the question bank. And once you're done, it should contain a list of question objects, each being initialized with a question and an answer. And the data is going to come from these dictionaries from the question data. So you'll need to think about how you can loop through that question data in order to create this list of question objects. Pause the video and give that a go now. All right, so we know that we need to create this question bank, which is going to be a list of question objects. So I'm going to start out just by creating an empty list, and then I'm going to loop through each of the questions inside the question data. And for each of these questions, I'm going to create a variable, which we'll call question text. And the question text is going to come from those question dictionaries from here. And if we imagine we have one of these dictionaries and we want to get hold of the question text, then we'll need to tap into the text key. So I'm going to put text inside here, and I'm going to do the same thing for the answer. So this is going to be using the answer key that we see right here. So now if we're looping through the first one, we should have a slug's blood is green and true for these two variables. So now I'm ready to create my new question, which is going to be created from the question class. And you can see that in the constructor, it's expecting two parameters. One is the question text, and another is the question answer. We can set the question text to this local variable called question text, and we can set the answer to the question answer. And of course, for simplicity's sake, we can also get rid of the named parameters and have them just as positional parameters like this. So now that we've created this new question object and saved it in the variable new question, we're ready to add it into our question bank. So we can say question bank.append, and we'll append each of these new questions that we create in the for loop. So now if I go ahead and print this question bank, you'll see that when I hit run and select my main file, then it prints out a list denoted by the square brackets, and inside the list you've got a whole bunch of question objects. And if you count, there's actually 12 in total, one for each of the dictionaries inside our question data. So very often when you're getting data from the internet or from somewhere else, it'll likely be in a format that's very similar to this. What we're doing is we're converting each of these pieces of data, which have a string key, which means it's very easy to make typos if we're using this in our code everywhere. And we're converting it into an object, which now has all of that data in a very easy and foolproof way of accessing the text and the answer. And you'll notice here that if I actually write the wrong thing, then it's actually going to highlight to me. This is not something that you can use. And if I start typing, I've also got the help of the auto insert. Now that we've created our question bank of question objects, the next step is to actually get our quiz up and running. Now that we've managed to create a question bank which consists of a list of question objects, the next natural thing to do is to actually bring up one of those questions and to ask the user to answer the question. Now, for all of the questioning and quizzing functionality, we're going to put that into the QuizBrain, which is going to be a class in its own right. And it's going to manage everything from asking the user for the next question, checking whether if their answer was right, and also checking to see if we're actually at the end of the quiz. You're going to be creating this QuizBrain class, and this class is going to have two attributes to begin with: a question number, which is going to have a default value of 0 because all our quizzes will start from the first question. And this is going to keep track of which question the user is currently on. We're going to use that number to go through the list of questions, which will be passed over to this QuizBrain object when it gets initialized. And then you're going to have a method which is called nextQuestion, which will pull up the question from that list depending on which current question number we're on. If you take a look at the final version of the quiz game, you can see that it displays the question number, Q dot, and then that number, and then it displays the question text, and then it asks the user for an input, true or false. This is what we're going to be focusing on in this lesson. Inside your quiz game start, go to the QuizBrain file and create the QuizBrain class. Add those two attributes. One is the question number, which starts out with a default value, and the other is the question list, which is going to be initialized when you create a new QuizBrain. And we're going to be passing over this question bank here into this question list when we initialize a new QuizBrain. Pause the video and see if you can complete this challenge. Alright, so let's start off by creating our new class, which is going to be called QuizBrain. And inside this class, we'll need to initialize some of those attributes. So I'm going to create the init method. Inside the init method, I'm going to create that first attribute, which was called question number. And I said we would set it to have a default value of 0. So this means every time we create a new QuizBrain object from this class, it's already going to have an attribute called question number that's set to 0. Now, the next attribute is called question list. And this is not going to have a default value. Instead, it's going to get it as a value passed over. So let's put that as a question list here and set it equal to question list. So what's going to happen is inside our main.py file, we're going to be initializing that QuizBrain, and the value that we're going to put in there as the question list is going to be the question bank. This way, we'll receive the question bank and it will be inside this question list attribute. Now, I have another challenge for you. Create a method called nextQuestion inside the QuizBrain. This method needs to retrieve the item at the current question number from the question list. And once you have this item, use the input function to show the user the question text and ask for the user's answer. Pause the video and give this a go. Alright, here's the solution. First, we're going to define a new method called nextQuestion. And this method is basically going to get hold of the current question And that is, of course, going to be from the question list. And then we're going to tap into that list and get hold of the item at the current question number. So for example, question number is going to start out being 0. And so it's going to go into this list, which is basically going to be our list of questions from our main.py, so our question bank. And remember, each of the items inside that list is a question object. And question objects have text attributes and answer attributes. So in addition to getting hold of the current question, we can then get hold of the current question text by taking the current question and then just simply writing dot text to get the value that's saved in that attribute. We're going to use an input to ask the user for what their answer is to this question. This is going to be an F string because we're going to be inserting the current question dot text. And at the very beginning, if you remember, we also have the question dot and then the number and then a colon. So that will be the self.question number. And then we've got our colon, and then it's going to be the question text. And then we're going to ask the user for a input, true or false. And that's it. That completes the challenge. Now, all that's left is to show the very first question to the user and run our code. Let's go back to the main.py and import the QuizBrain class. So we're going to say from the QuizBrain file, import the QuizBrain class. And once we've created our question bank, then the next thing to do is to create our new quiz. So this is going to be a new QuizBrain object. And when we initialize it, we have to pass in a list of questions. And that is, of course, going to be the question bank. So now that we've got our quiz up and running, then we can say quiz object dot next question. Let's go ahead and run this main.py file. And you can see we get our question text being displayed, true or false being asked, but our question number starts from 0. And that is, of course, because we need 0 here in order to get hold of the first question from the list. And that's why this has a default value of 0. But by the time we reach this input, it would be really good if this actually read 1 instead of 0. So one way we could do this is we could do this plus 1, but remembering that we actually need to increase the question number every single time we call next question anyways, then once we've gotten hold of the current question, we can actually tap into that self.question number and increase it by 1. This will have the same effect, and if you look at it now, we've got the right question number being shown here, the right text being shown, and then we can insert true or false. Now at this stage, our program is just going to exit. In the next lesson, we're going to have to work out a way for our questions to keep being asked, and we'll need to write some more code for that to work. In the previous lesson, we managed to get our QuizBrain up and running and to start asking the user for their answer. But currently, there's no way for our program to continue to the next question once the user has typed an input. However, if we take a look at the final version of the quiz game, you can see once the user's typed an input, it then goes to the next question and shows them the question number 2 and the question text for that second question. How can we create that functionality to work with our QuizBrain? Well, if we could create another method called still has questions, well then inside our main.py we could probably create a while loop, and the while loop checks if the quiz still has questions remaining. Well then in that case we're going to keep going to the next question. So how do we create this functionality, and how do we create it inside the QuizBrain? Your job is to create a new method here, which is going to be called still has questions. And this is going to return a Boolean, either true or false. And depending on that Boolean, we can get our while loop to keep working and keep running and looping, or we're going to get the loop to stop once the quiz has run out of questions. Here's the behavior that you're looking for by the end of the challenge. The while loop should continue serving up the next question to the user until we reach the end of the quiz. Have a think about how the question number and the length of the question list relate to each other and see if you can complete this challenge. All right, so we know that we can get the length of our question list by using the len function. Currently, in our current version of the question bank, we have 12 questions in total. So the length is going to be 12. Now we want our loop to keep going until we've reached the number of questions in our list. What we could do is we could check to see if the self.question number is less than the length.self-question list. In that case, we'll return true, but otherwise we'll return false. Remember that this question number gets increased every time we show the user the next question. It starts out being 0, and then it goes immediately to 1, and then we get to the end of the next question function, and we get to our while loop. So in our while loop, we can check to see if the quiz still has questions, and if this is true, then go to the next question, but if it's false, then exit the loop, and we're at the end of the game. Back inside our quiz brain, we can actually simplify this method even more, because we know that this is going to be evaluated by the computer and it's going to be either true or false. If it's true, then it goes into this block, and if it's false, then it goes into the else block. We can actually save ourselves all of this effort by simply just returning this expression. Now what it's going to do is, let's say that A is equal to 5 and B is equal to 3. And if we were to return 5 is greater than 3, then this is basically the same as this expression, which gets evaluated by the computer. And when this code runs, it's going to be either true or it's going to be false. So that value is then going to be straight away returned by this method back into this while loop to see if we should continue going to the next question or not. So let's run this file, and you can see it asks me the first question, and then it's going to go to the next question, and then it's going to basically keep going until it gets to the end of the list of questions, and then it ends our entire program. In the next lesson, we're going to figure out how we can check the answer that the user has inputted here and see if it's actually the correct answer. Currently, when we run our code, you can see that while we can input our answer, our code doesn't actually really care because it's not checking to see if it's right or wrong. In this lesson, we're going to add one more method to our quiz brain, and that's the ability to check the answer that the user inputted and see if it was correct. And that means we need to keep track of the user's score. So we'll add another attribute, score, which has a default value of 0 to begin with, and it'll increase every time they get a question right. So in this lesson, we're going to create a new method called checkAnswer. And this checkAnswer function is going to be used to see if the user's answer, which comes from this input, is the same as the actual answer to the current question. What we need to do is we need to save this user's input inside a variable, which we'll call userAnswer. And then I'm going to call our checkAnswer method, and I want to pass over the user answer. Now, in addition, I also want to pass over the correct answer. And the correct answer is going to be the current question dot answer. So let's replace that with current question dot answer. Because we know that current question is a question object, which has a text attribute and an answer attribute. And once we've passed over the user's answer and the correct answer, then we can receive it inside our check answer function as a parameter. So we'll call this user answer, and the second one we'll call the correct answer. So now this input is going to be passed over here, and the correct answer is going to be under this variable name. So now we can see if the user answer is equal to the correct answer, and just for safety's sake, it's usually a good idea to drop both sides to a lowercase so they're comparable. This way, just in case the user answers true or true, it will be treated exactly the same. If the user answer matches the correct answer, well then this means that they got it right, so let's print it. But on the other hand, if that was false, then that means they got it wrong. So let's tell them that's wrong. Now, it might also be a good idea to tell the user what the actual correct answer was. Now, you have a choice depending on where you want to put that. So you can either choose to only show them the correct answer if they got it wrong, like this. But I think it's actually a good idea to show them the correct answer even if they got it right. So I'm going to change the indentation so that it's actually outside of the if-else block. And it's just simply going to happen once the if-else block is complete. Now, the next thing to do is to keep track of the user's score so that every time they get a question right, then it should increase the score by 1. Pause the video and add a new attribute called score to the QuizBrain class and increment it by 1 every time the user gets it right. Now, what you're aiming for is to be able to print out the score and the current question so that you can tell the user your current score is and print it out after every single question. Pause the video now and complete this challenge. All right, so let's go ahead and create our new score attribute, which is again going to have a default starting value of 0. And then whenever the user gets a question right, then we're going to increase their score by 1. So we'll tap into that score attribute and then increase it by 1. Now we've got our score being tracked, then we want to be able to print out what the user's current score is. So at the end of check answer, let's create another print statement which gives the user their score. So your current score is, and then we'll insert the self.score, and we'll also tell them out of a possible number of questions. So we can insert the self.question number. So this means that they've completed 5 questions so far where they've had 5 chances to get things right. Then we can show them that they got however many right out of those 5. So maybe they got 3 out of 5 right, or maybe they got 5 out of 5 right. And now if we run our code, we can see that print statement in action. So it tells me that I got it right, and then the correct answer was true, and that my current score is 1 out of 1. Now, if I get one of these wrong, then you can see that my current score is now 3 out of a possible 4. And it tells the user that they've missed out on 1 point. It'd be nice to add a little bit of space in between each of the questions. I want to be able to see all the questions that I've done so far, so I don't want to clear the screen, but I want to be able to add a new line here. So at the end of my print statement, I'm going to add a print, which is just going to print a new line. So that in between each question, I have a little bit of space to tell each question apart from the other. The final thing I need to do is to tell the user their final score once the entire quiz has finished. And we want to be able to print something like, you've completed the quiz. And then we'll print out something like your final score was, and then we'll give them their final score. So maybe they got 10 out of 12, correct? And this way they can see what their final outcome was. So have a think about how you might be able to print these two lines here and how you can get hold of the question number and the user's score to print inside our main.py. So pause the video and complete this challenge. All right, so the first line is very easy to print. All we need to do is wrap a print statement around it. The second line is a little bit more tricky because we'll need to have an F string. So we want this second value to be the total number of questions in the question bank. Or it could be the current question number that the user is on. You can do either. You can either say question bank and wrap a length function around it, like this, which will give you the total number of questions because we're at the end of the quiz now. Alternatively, you can also tap into the quiz object and get the question number when the quiz ended. And similarly with the score, you can say quiz.score. So now, once the quiz has completed, you can see our print statements. You've completed the quiz and your final score was 0 out of 12 because I was just button mashing and I didn't get any questions right.